So thank you very much for the introduction, and hello everybody. So is Hyper-converged the only way to the software-defined data center? I think this is really an interesting question, and I'm happy to be here on the stage to do together with you this reality check of hyper-converged infrastructures. You know, there is so much noise and so much talk out there about digitalization here at the event and out there in the market. So I do not want to stress this topic too much because everybody is doing it. But let me make one statement. In the digital age, we are faced with an ever-increasing amount of data. And this data needs to be collected, it needs to be transported through the networks, it needs to be processed and analyzed, and it needs to be stored. And this has, of course, a huge impact on data center infrastructures, on the servers, on the network, and on storage. And from a customer's perspective, the needs are crystal clear. You know, as the data is ever increasing, scalability needs to be fast and flexible. On the other hand, resilience is key because infrastructures need to run 24 hours a day. And of course, they should be managed in a simple and in an efficient manner. And if you compare this with traditional data center infrastructures, which are admittedly hardware defined and therefore rigid, where management happens in silos, where you need dedicated teams for the compute resources, for the storage resources, and for the network resources, where certainly there may be a certain level of automation, but most of the things still need to be done manually during operation. And this means, of course, things are very slow. So in a nutshell, a traditional data center infrastructure is complex, it's inflexible, it's expensive, and it requires really great skills inside the IT department. And the exciting question is now, how can we change the game? And there is certainly not only a single answer to this question, but one of the answers is hyper-convergence, hyper-converged infrastructure. And there is so much noise in the market, and sometimes I got the impression that not everybody has the same understanding what hyper-converged infrastructure means. And just to make sure that we are all on the same page, I want to briefly summarize the main characteristics of hyper-converged. So first of all, we understand by hyper-converged it's an interconnected or it's standard servers which are interconnected, where we don't have an external storage, where storage spreads across the local disks of the servers in that cluster, where we do not have a physical storage area network, where we have a virtual one instead which spreads across these local disks of the cluster servers, where data services are integrated, such as data replication, deduplication, compression, snapshots, data tiering, whatever you know from external storage systems. And actually, as a consequence, high availability is built in, because whenever one of these servers fails, there is still another one that can run the workload of the failed server, and data will not be lost due to the feature of data replication. On the other hand, there is a unified central management for both compute resources and storage resources. And the absolutely great thing is the ease of scalability, be it in terms of performance, be it in terms of storage capacity. Whenever storage capacity or compute performance is scarce, then you just add a server or a couple of servers. These servers will be automatically discovered, and the integration with the existing cluster will be very, very easy because everything is software defined. And resulting from these characteristics, basically, we can derive a lot of benefits. As we have no external storage, there are less components involved. These less components require less space in the data center, energy consumption is lowered, cooling requirements are reduced. As we said already, The administration efforts can be reduced. Everything becomes simpler because storage and compute is more or less managed in exactly the same way. People say that lower skills are sufficient, which means from a company's perspective that even lower paid staff could do the same job. And the great thing is, as a consequence of scalability and ease of scalability, that you really can start very small, exactly with an infrastructure that meets your requirements. And when your business grows, then actually you can grow your infrastructure as you go. And this means for you in the IT organization that you can flexibly align the infrastructure to the business, to the demands of the business. You can demonstrate a great responsiveness towards the business, and due to the built-in high availability, business continuity will be ensured, and at the end of the day, it's even the total cost of ownership that can be lowered. And doesn't this sound great? Many people think that this sounds great, and this could easily lead to the conclusion that hyperconverged is the silver bullet of IT. But the question is it this really? So before answering this question, I want to compare both architectures here on one slide. On the left-hand side, the classical one. On the right-hand side, the hyperconverged architecture approach that we've just discussed. So with classical, we have servers, we have a local area network for the connection between these servers, we have external storage systems, we have a storage area network for the connection and for the data traffic. And this means we have multiple components, and for these multiple components, lifecycle management is needed. And usually, these different components have different life cycles. Moreover, we have to state that two separate networks need to be maintained. A storage network and the local area network. And I'm pretty sure some of you might be saying, well, of course, the local area network can also be used for the data traffic, for the storage traffic. You are absolutely right. This is possible. So from a physical perspective, you are right. But from the logical perspective, this still requires the maintenance of two different networks. Classical architectures, as I said at the very beginning, are hardware-defined. With hyperconverged, we speak of software-defined for compute and for storage resources. What about scalability? For classical, actually, scalability works by adding multiple components, and here primarily separately. That means if today you figure out you are run out of compute resources, then you add maybe servers. If tomorrow you figure out you run out of storage capacity, then you add storage systems, or let's say disks within the storage system. With hyperconverged, scalability always means adding servers. And primarily this is done linearly. So that means whenever you need more compute performance and you add servers, you automatically will get more storage capacity as well. Of course, there are solutions where this is not mandatory, but on the other hand, the ideal procedure with hyperconverged is to go this linear approach. And what about storage activities? Well, on the classical side, the storage activities are of course running in the external storage system. Means they are totally separated from servers. Whereas on the hyperconverged side, actually, servers are of course involved in the storage activities because we do not have anything else but server storage is on the servers. And this needs of course to be considered when sizing the compute resources. When we started our hyperconverged business some 3 years ago, a rule of thumb that we always used for the sizing was reserve around 10% of your available compute resources for the storage traffic. This was at that time already a very conservative estimation. And meanwhile, of course, the performance of the CPU resources have gone up. So I would say the reserves that you should really spend for the storage traffic are even much less in the meantime. And just talking about the maturity of both architectural approaches, classical, of course, has been in the market for many, many years, I would almost say for decades, whereas hyperconverged entered the market, I think, initially some 5 years ago, but some 3 years ago, actually, it was getting more mainstream. And the question, of course, for you might now be, what do these differences that I just tried to explain, what do these differences mean for you? So basically, the classical architecture could be used for general purposes, no matter whether a workload has to run bare metal, meaning has to run on a physical platform, whether it has to run in a virtual environment or can run in a virtual environment, or if you need an infrastructure that requires multi-hypervisor environment for multiple applications. No problem. With a classical approach, you can do. With hyperconverged, actually, virtualization is a must. And depending on the implementation of hyperconverged, very often it is based on a single hypervisor. Just to consider this. On the classical side, we have a certain level of hardware dependence, and this is primarily related to the storage system. As we do not have a storage system with hyperconverged, of course, we do not have this hardware dependence anymore, but instead, we will have a software dependence related to the virtualization software. And a last point that I want to bring into play here is the software licensing. I think those who have grown up with classical architectures, they are pretty much familiar with the software licensing models of your software vendors. With hyperconverged, actually, you might be faced with some commercial restrictions. For example, there are database vendors whose license policies look like this, that you have to pay license fees for every CPU or every CPU socket or every CPU core, where in theory a certain workload will run. And as with hyperconverged, everything is more or less transparent to you. You do not know where it runs. So actually you would have to pay license fees then for all these CPUs or CPU cores, and pretty soon, therefore, this could get to a no-go situation with regards to commercial considerations. When it comes to complexity or operational complexity, we have to say it's definitely lower on the hyperconverged side because storage and compute is managed in a unified manner. When it comes to acquisition cost, to purchase cost, we have to say with classical, the hardware costs are higher and the software costs are lower. And with hyperconverged, it's actually vice versa. Yeah, hardware cost will go down because you don't need an external storage, but instead you need the virtualization software that makes hyperconverged and software-defined storage happen. And the last comment here on the vendors. With classical, well, you know all the well-established vendors that have played this game for decades. With hyperconverged, actually, it was some newcomers that introduced hyperconverged into the market. Meanwhile, there is a considerable number of these newcomers, but the established vendors, they have also jumped onto this train and consider this as a great alternative to the classical approach. So in a nutshell, we could say after this comparison and after considering here what these differences mean for you, we could say both approaches provide unique advantages. With classical, it is actually the general purpose use case. With hyperconverged, it is actually the definitely lower operational complexity. And from our point of view, there are good reasons for both architectural approaches to coexist. And I'm pretty sure that some of you might be wondering now, but so what? What does it really mean for me if I have a certain use case? Which way should I go? Should I go classical or should I go hyperconverged? And before going deeper into this slide, I want to say there is no black and white answer. It will definitely depend strongly on the use case. And that's why I just want to give you a hint here, a couple of aspects that should be considered when you are faced with such a question. So in the first place, it's about the workload. The question is, does your workload for which you need an infrastructure, does it need scale out or does it need scale up? If it needs scale out, well, we could say there is so much that speaks for hyperconverged, because hyperconverged is designed for scale out, and especially if compute and storage needs scale in tandem, meaning if you need more compute, you also need more storage. If this is the case, as for example with VDI, with virtual desktop infrastructures, you know, if you have virtualized, for instance, 500 users, and you assume that these users have more or less all the same user profile and more or less the same resource requirements, and then you want to virtualize 100 users more, then it is very easy to add a server or two servers in order to make it happen. So that's great stuff for hyperconverged. But if, on the other hand, it's more about scale up, it's more about a granular expansion on the component level. As I said before, today you need more compute, tomorrow you will need more storage, etc. Or you will only need more storage, then actually the classical approach will outweigh usually the hyperconverged approach. Then the question is, which growth is expected? I try to bring across that ease of scalability. That's a great point on the hyperconverged side. Yeah, but if you do not need this scalability because there is no growth expected for your infrastructure, you won't be able to take advantage from it. Another thing is remote offices, branch offices. There are customers that are totally unhappy because they have to look after the storage area networks in these remote offices. They have the skills somewhere at a central place, and because there is so much trouble again and again, they have to travel a lot to these robos. And they are quite happy if they can replace the storage area networks by hyperconverged infrastructures that allow them to manage them from a central point without traveling all the time. And then I said already, hyperconverged usually means dependence on a single hypervisor, and also means as a prerequisite there is a virtual environment. So if multi-hypervisor or bare metal operation is needed, then I would say much speaks, of course, for the classical approach. And then you could ask the question, well, do my workloads benefit from the data services? If this is the case, you could say, oh, that's great. I need something and it's anyway there, then I don't need to pay extra for it. But if it is the other way around, if you will not benefit from these data services, you could say, okay, then I implicitly pay some money for something that I do not use. So it's always a matter of consideration. And we said the management, because it's unified for compute and storage, is really a great advantage. But Is it a great advantage for your organization? Is your organization prepared for this? You might have existing storage skills in your organization, and you might expect resistance from these storage guys if you want to take something from them away. And the question is, do you want to be faced with this? Do you want to be faced with this resistance or not? And then it might depend on the storage strategy. There are customers saying, whatever I newly introduce in my organization, I use the storage from vendor XY that I have already had in place for years. If this is your strategy, then maybe Hyper-converged does not perfectly fit into this scenario. If, on the other hand, external storage and SAN causes headache all the time, and you want to get rid of it, then Hyper-converged could maybe a good first step into that direction. But what should we also take into consideration? This is the storage capacity that you are faced with. You know, today, usually every Hyper-converged solution has a maximum number of compute nodes. And with this maximum number of compute nodes, of course, the storage capacity will be also limited. You understand what I'm saying? So that means if your storage capacity is larger than the storage capacity for the entire cluster, then of course Hyper-converged is not the right way to go. And software licensing, I need not repeat this because I mentioned this already before. And at the end of all these considerations, it will end up in a cost comparison for CapEx and for OpEx. And even there is no general answer what is, in terms of CapEx, cheaper or more expensive. So our recommendation in this context is things should be decided per each use cases. If the benefits outweigh the drawbacks, the recommendation is okay, then go for Hyper-converged, but this needs to be analyzed in depth. So at the end, it is the use cases that matter, and the business requirements, meaning your business requirements, should determine the optimum approach. Okay, and from Hyper-converged to software-defined data center, it's actually only a minor step, because we said Hyper-converged means software-defined compute plus software-defined storage. By definition, a software-defined data center includes the two, but in addition also the software-defined networking. So if you add software-defined networking and you add a platform that is able to automate provisioning, configuration, and operation based on policies, then actually you have already a fully fledged software-defined data center where everything is virtualized, where you can use any hardware. The hardware does not matter anymore, it's just the software. And as I was developing now my story from Hyper-converged to SDDC, you should not come to the conclusion that SDDC always means based on Hyper-converged. A software-defined data center can, of course, also be based on a classical architecture. I will show you an example in a minute. But at the end, I would like to state, with a software-defined data center, you have something in your hand that is simple, that is fast, that is flexible, and also efficient. And this should be the right answer to digitalization that we were starting with. And after having laid the basics here, the question is how to get your infrastructure up and running. And if you do this in a do-it-yourself approach, I pretend that this is error-prone, time-consuming, risky, and expensive, because you first of all have to do the design yourself. You have to select from a myriad of software and hardware products. You have to do the integration of the components by yourself. You have to work off a very complex test matrix, because compatibility of the components is not always ensured. And only after this lengthy process, you can then start with the on-site deployment and the integration into your production environment. And that's why we think there is a better approach, and this is the integrated systems approach, where all these lengthy tasks, design, integration of the components, working off the test metrics, has already been done before your project even starts, so that your project is basically limited to the on-site deployment and the integration into the production environment. And this brings basically my company and Fujitsu integrated system PrimeFlex into play, which is a pre-configured, pre-integrated, and pre-tested combination of data center components such as server storage, network connectivity, and software, where we think that this is the right means to reduce complexity, project time, also the risk that things will not work at the end of the day as expected, and also cost. And on the other hand, it is a sound foundation to increase your operational efficiency, relieve you from painful things, and give you more time back to focus on the really important things of the business. And just to let you know a couple of characteristics of our PrimeFlex family. It is an entire family of integrated systems. So we are addressing business critical use cases. You will see them in a minute. But related to this session, it's important to state this family includes classic converged systems and hyper-converged systems, meaning we as Fujitsu, we have no reason to push you into one or the other direction because we understand this or that better. Our approach is in a kind of co-creation process to elaborate together with you the ideal solution that meets your business requirements, be it converged, be it hyper-converged. And there are standard sizes available that we ship ready to run, meaning they are even pre-installed in the factory. But of course, we understand that one size does not fit all. You may have requirements that we cannot map up front. And for this purpose, we offer flexible reference architectures that can be customized to your specific requirements. And all of this is based on best practices and a long experience. And for those who do not know, I want to state that our company was the first one who shipped an integrated system back in 2002. And the successor of this integrated system, by the way, is still alive today in the SAP arena. PrimeFlex is based on our own technologies, but of course also lots of partner technologies, no doubt about it. And another really important comment is it's not just boxes, it is supplemented by flexible services options throughout the entire life cycle of the product, from consult via design, on-site deployment, integration into the production environment, overall support with a single point of contact. And these services are either delivered by ourselves or by our local partners that we also need for this. So these are here the focus areas where PrimeFlex, where we are playing the game with PrimeFlex. We have no time to go into all the details. I just want to focus here on virtualization, where at a first glance it might be a bit hard to understand for some of you how these 5 offerings that there are in place are positioned, but I think the explanation that you are going to hear now makes it better understandable. On the upper half of the slide, there are hyper-converged systems, 4 of them. On the lower half, it's the classic converged system. On the left-hand side of the slide, we see those being based on VMware technology, and on the right-hand side, those being based on Microsoft technology. And if we are going a step further, I try to add here the maximum number of compute nodes. You get a certain feeling, a certain impression, how far we can scale the individual offerings. You also might see the difference here. What I want to point out is PrimeFlex for VMware Cloud Foundation here is not just a pure hyper-converged system with software-defined compute and software-defined storage. It is a fully fledged software-defined data center, including software-defined networking, which can be scaled to 192 nodes. The PrimeFlex V-shape here at the bottom actually, and you can see this from the slide, gives you choice in terms of the virtualization technology, either VMware or Microsoft, and gives you even choice in terms of the external storage system, Eternus from Fujitsu, and NetApp storage systems as well. And all these virtualization offerings of the PrimeFlex family are based on Primagy servers. And why am I saying this? Primagy servers are the absolute world champions in terms of virtualization. It's the most powerful virtualization platform. And this is a slide just showing the situation of the last 5-6 years. And whenever you see red here, it means my company, Fujitsu. We have been the world champions, not only once here and there, but almost over all the categories of this de facto standard of virtualization benchmark, which is the VMark benchmark, and you see continuously over the last 5 or 6 years. The headline of my session included the word software-defined data center. I said it already on the hyper-converged side. PrimeFlex for VMware Cloud Foundation is our offering of a software-defined data center that is even shipped ready to run, which is pre-installed in the factory, which is even ready to operate within a very few hours. And if you need something with a classical architecture, and even if you are in favor of open source or OpenStack, then PrimeFlex for OpenStack would be a choice for you, where we give you the flexibility to choose between Red Hat and SUSE. And this leads me already to my summary. What are the most important key takeaways of my session here? So Hyper-converged is definitely a rising star. You see this in all statistics out there. And you saw from my presentation that there are lots of benefits that can be derived, and it is a great springboard to the software-defined data center. But it's not the holy grail. Use cases matter. And no matter whether it's classic or hyper-converged, which is ideal for you, integrated systems will help you reduce complexity, time, risk, and cost, will also help you later on to increase your operational efficiency. And with the integrated system from my company, Fujitsu, which is PrimeFlex, we give you choice in terms of converged and hyper-converged, not pushing you anywhere, just pushing you to the ideal solution that you need for your business. So if you are once wondering if hyper-converged is your way to go or not, I can just encourage you to have a word with my company, Fujitsu. Thank you very much for your attention.